Hello, today we're going to be looking at statistics, which is basically a way of dealing with numbers. As engineers, you'll get a lot of numbers, so it's helpful in being able to deal with them. So statistics is the collection, evaluation, and interpretation of data. As an engineer, you might get all kinds of data from a process or from if you're in charge of people, sick days and things like that. So there's two types of statistics: descriptive statistics, which describe collected data, and inferential statistics, which generalize and evaluate a population based on a sample data. So as far as data goes, you can get categorical or qualitative data, basically non-numbers, colors of M&Ms, the breeds of dogs, things like that. Or you can get numerical or quantitative data, which is basically numbers. So ways of collecting numbers, you can just collect it randomly. You can use some sort of system to collect the data, like every fourth person. You can collect stratified data to make sure that you get a certain amount of each subgroup. So let's say you wanted to get, at least 50% of your data from boys and 50% of your data from girls. You can sample a cluster and just select everybody in that group, or you can just collect data from convenience, basically asking your friends things like that. As far as graphing it goes, you can graph it with a histogram, which looks a lot like a bar graph, or you can graph the data. You can graph frequency polygons, which basically looks a lot like a line graph. You can graph it in a bar chart or a pie chart. You're all familiar with that. So ways of dealing with data. One is very simple. We're all familiar with calculating. It's just the mean or the average. The symbol for the mean is X bar. There's this line over it. Basically, you all know what to do. You add them all up and you divide by how many you added. So the sigma here means sum, add them up. And then n is the number of data points that you had, the numbers that you added and you divide by. So most frequently used measure of central tendency. Strongly influenced by outliers. So let's say you had a couple ones that were really far away from the average, that they tend to skew the average. So determine the mean value of these numbers. So basically they add them up, and there were 11 of them, so they divide by 11, and the average was 47.64. The median is kind of like the median in a road. It divides it into two halves, or two equal parts. So basically, you've got to put the numbers in order from low to high, and it's useful in situations with skewed data and outliers. So somewhere where you've got some people that are really far apart from the average. So organize them from high to low. Basically, and then find the middle. In this case, it's going to be 58. And then you've got 5 numbers to the left and 5 numbers to the right, and that's your median. Okay. So what if the data had an even number of values? What you would do is you would take the average. So in this case, it'd be 58 and 59. You would just take the average, and it'd be 58.5, and that would be your median. Okay, there's the mode, which is the most frequently occurring number in your data set. If you were to graph it on the number on a graph, it would be the highest point. It may not be typical. It may not be close to your average. You may not even have a mode. You may have more than one mode. It all depends on the data. So determine the mode of this. So we've got two 63s, so the mode is 63, so there's just one mode. If you look at this one, it's got two 63s and two 59, so there's two modes, bimodal. And in this case, there's 3 modes. So I don't see why that's amazingly important, but that's the deal. Measuring how far the data is scattered. So is the data really close together, or is it really, really spread out? So one way of dealing with that is what's called the range. This is really easy. You just find the highest and lowest number, and then you subtract them. And then there's a little bit more of a, important tool, standard deviation. This tells you a little bit more than the range does. So it's got more uses. And we'll show you how to calculate that. It's just kind of repetitive. So the range, you just find the highest and lowest value and subtract them. So 63 minus 2, the range is 61. So pretty straightforward. Standard deviation, that's got a little bit more to it. If you're just taking the sample of a population, you use the sample standard deviation. If you're testing the entire population, you use the population standard deviation. And you can read all this if you want. Okay, so how you do that is you find the average, okay, and you look at each number and you subtract it from the average, and then you square that difference. Okay, and then you square all of those differences. Okay, you add all those square differences, and then you divide by the number of values minus 1, and then you take the square root of that. So we'll go through that. So first off, we'll find the average. So we've already done that, 47.64. Then we got to do this little part here where you subtract each number from the average and square it. Okay, and that S should be a sum. I don't know why it's not a sigma. So 2 minus 47.64 squared, 5 minus blah 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 squared, etc., etc. So this gets to be, you would have a computer do this for you. You wouldn't realistically do this by hand. Excel will do this for you very, very quickly. That's one of the nice things about Excel. It's meant for dealing with numbers and is a very powerful tool. So then we add all those numbers up that we just squared, okay, and we divide by how many we had with minus 1, so that's 10, and then we square root that answer that we just got, and we got an answer of 22.41. So this number basically gives you an idea of how spread out your data is. Is it close to the average of 47, or is it pretty spread out from the average of 47? So is it clustered, or is it not close to the average? So calculating the population standard is pretty simple. Is pretty similar. I'm going to go through this very quickly again. Find the average, subtract each number from the average, and square it. It's the same basic process. And then add all those up, divide by the total number. You don't subtract 1 from it, okay, and then square root that, and you get 21.4 is the population standard deviation. I'm certainly not going to make a big difference between those two. Graphing a frequency distribution. Theoretically, you did this when you did the coin flips or was it the cards? I think it was dice. You graphed the likelihood of getting a certain number. So in this case, they're doing it for a coin toss of three tosses. And they're looking at how many heads you get in each toss. So a coin is tossed 3 times. Assign X to represent the frequency of heads in each toss. So X is 1 when these 3. Okay. So calculate the likelihood that an experiment variable will occur within an experiment. So calculate the probabilities. So basically it's the frequency over the total. So the likelihood of not getting of scoring no heads is basically 1 over the total of 8. Calculate of flip a coin being heads once is going to be 3 out of 8 because there's 3. Of having it twice would be 3 out of 8. And then calculating it for getting it 3 times, it's just 1 out of 8 again. Graphing this basically is a bar graph with the probability on the left side, and then the result on the bottom. So 1, 3, 3, and 1 again. So again, I'm not going to make a very big deal about that. So here we've got a histogram for available airplane passenger seats 1 week before departure. What percent of the time you had this many open seats. So you see the most frequent event was having 5 seats, etc. All right, that is it for that. Make sure that you can calculate the mean, mode, and median for a set of numbers, and do the worksheet that goes with this.